and good afternoon, everyone. Dear authors and invited guests, welcome to Technical Session 9A. Myself, Adesh Bazare, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the ninth International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held on 4th of April 2025 in Bangkok, Thailand, and the virtual event is being held through Zoom on 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 8 minutes, I'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Before we start the session, I would like to introduce you all to the chair for this session. Van Beek Nguyen is a lecturer at Ho Chi Minh City Open University, Vietnam. His expertise lies in artificial intelligence, artificial neural networks, and human computer interaction. He is committed to advancing research and education in these fields, fostering innovation in AI driven technologies and interactive systems. So, may I now invite you to share your opening remarks with us?
Hello, everyone. I'm sorry
Hello, sir.
for you can hear me.
Yes, sir. You're audible.
And so now we begin the session today, right?
Yes, sir.
Yeah, thank you. So good afternoon, everyone. It's my great pleasure to welcome all of you to this technical session of the International Conference on Trends in Informatics System, ICTIS 2025. My name is Nguyễn Văn Bảy from Ho Chi Minh City Open University, Vietnam, serving as the session chair for this session, alongside my esteemed co-chair, Prof. Smita Arawal. We are honored to be here today with all of you, distinguished presenters, fellow researchers, and participants from across institutions and industries. This session will be feature 10 presentations showcasing cutting-edge research in various domains such as machine learning, cybersecurity, medical imaging, IoT, and natural language processing. So we kindly ask all presenters to stay within the time limit to ensure the smooth and timely flow of the session. So we will have only 12 minutes for the whole presentation. We all so now let's now begin our first presenters. Our first presentation is titled A Machine Learning Framework for Anomaly Detection, Isolation Forest, and SVM Insights. So let's welcome our presenter, Payo Danisa. So Ms. Payo, the floor is yours.
Fire ma'am, are you in the session?
Yes, sir. I'm here.
Yes, ma'am. You may begin your presentation.
Okay. Is this visible to everyone?
Yes, ma'am.
Okay. Good afternoon, everyone. I Payal Dhanesha, Assistant Professor in the GLS University, Ahmedabad, Gujarat, from India. My topic is a machine learning framework for the anomaly detection, isolation, and SVM. So here, the anomaly detection, it's play a very important role to identify the unusual patterns or the behavior across various domains. So including like cybersecurity, finance, healthcare, and industry system like this. So in this, I have combined with two different algorithms, isolation forest and SVM, to enhance some accuracy and efficiency for the anomaly detection. So here I'm go with my introduction, like the fraud detection. It's a essential part, or it's a play a very critical function for the financial institutions and the company, and that it helps the assets to maintain customers trust and comply with the regulations. The main use of this technology is to identify anomaly detection for its efficiency, scalability, and simplicity. The main core idea behind the isolation forest is that the anomalies, to find out the anomalies are the cues and the significantly different from the normal data. So basically, it's a very difficult to identify that the anomaly from the all of the certain data. So that's why I have used this isolation forest algorithm and implemented it with the SVM technologies, with the SVM algorithms. So here I have did some literature review, lots of literature reviews I had read it, and so here I'm not going to go with this literature review, but after this all of literature review, I'm I try to implement the isolation forest on my data set, and how the isolation forest it work right now. The algorithm it builds some uh, it's an assemble of the random trees. So random in on a different random trees, it's pick the different transactions, and it goes with some split the data until it's found some anomalies. So here I have implemented the isolation forest on my data set. Here is my data set, different parameters that you can show, like transaction date, transaction time, credit card numbers, its categories, amount, and the full address, state, and here are the other different parameters. The isolation forest that builds, which work with some different uh, random forest algorithms. So basically, it works like a random forest, but it's not exactly like the random forest. Here, it's a few steps for how the isolation forest is work. The transaction, there are some new transactions if arise, and the existing transactions arise, then the isolation forest finds its work on the different transaction. It split all the transactions into the various ways, and it splits transaction into the different section until it's found some anomalies, and that it put some score outputs. If it is a fraud, then it would put a 1, and if it is a considered as a normal transaction, and it put a 0. So at the end, that we if there is a 1 in a transaction field, then it considered as a fraud transaction. Here I have also generated the heat map. It's according with my parameters. The heat map, it shows a much wider and some irregulation distributions. There are lots of parameters that you can see over here, and from this, I have also generated a histogram for the transactions amount. The transactions, and you can see this is uh, here I have implement all these histograms is generated more than 5 lakhs data. Yeah, in my data set, there are more than 5 lakhs data are there. And the isolation forest that efficiently that detects the outliner by the isolating data and pointing that behave differently due to some unusual transactions. Sorry. In this isolation forest, and you can see there are some normal transaction and you can identify some anomaly transactions. Here the red points that demonstrate the broad capacity of the isolation forest, and it handle with some local and some global transactions. In the next, here I have also recognized some ROC for the isolation forest and SVC. The left image that you can see, the AUC curve, it's 0.68, and in the right AUC curve is 0.84. So this is the high accuracy that shows SVC is the more accurate at the distinguish between the normal and anomaly detection. And the in the left side that image, that model is better than the random forest, but not in a highly recommended in every time. Here I got some results like the anomaly detection. In this anomaly, I found that we have the more than 5 lakhs data in my data set, and the normal transaction considered up to 550161, and I found the anomaly transaction there are more than 5,000. So here we can identify that which are the fraud transaction and which are the normal transactions. The comparison between two models like the isolation and the SVC model, the accuracy I found that the isolation model is 0.72%, and about the SVC is a 0.81%. And I use ROC and IOC score, which is 0.68% in 0.68 in isolation forest and 0.84 in a SVC model. So here we can also implement like in a future enhancement that I can consider like for integrating deeper learning models like encoders for the better anomaly detection. We can also implement some blockchain for the future work. We can also implement some real-time fraud detection system on the real-time data, and we can also combine, or we can create some hybrid model to find the better accuracy from this model. Sir, if you have any questions or suggestions. Hello.
Yeah, thank you for the presentation. So we will have the older participants today. So do you all have any question for the speaker today? So if you have any question, please feel free to raise your hand or typing the question into the chat box of the Zoom.
If anyone has any questions or suggestions to raise for the particular paper, they can ask it. Okay, so as there are no questions or any suggestions, we'll move towards our next presentation. Thank you, Kyle, ma'am.
Okay, thank you so much, sir.
Sorry,
Yes.
I think I will give some suggestion to you. Actually, just my some of my experience and make it better for the next time, I think. So for the presentation, you can add something. The first, you have to add the slide number, so that if I have any question on each slide, I will go directly to the slide. Can you
Okay.
hear me? Yeah.
Okay,
And
okay, sir.
also, yeah. And also the visualize like charts or images. You can make it
Oh,
bigger. Yeah, and
okay.
make it
Yes, sir.
clearer.
Definitely, I'll
And
contact you if I found any difficulty in my research. Definitely, sir.
yeah,
Vadira
don't
sir,
worry.
Vadira sir, please share this number and just email so we can communicate with it for the future work.
Yeah, thank you for that.
Okay, thank you so
Sure,
much,
ma'am.
sir.
Sure, ma'am. Yes. Okay, so we'll move towards our next presentation. Our next presenter is Pimal Khanpara. Will be presenting a paper on a novel zero knowledge proof-based verification and authentication protocol ZKPVA for web security.
Yes, on behalf of Pemal ma'am, we'll be presenting the paper. So just a second.
Sure, sir.
Is my screen visible to you?
Yes, sir. Your screen is visible.
On just a second, I'll do a slideshow. Yes. So, yes, we'll be starting off with the presentation. Greetings to the all panelists present over here. So this is Raj Mehta, and on behalf of Pimal ma'am and Prasham Shah, I'll be presenting the paper. So my paper is a novel zero knowledge proof based web authentication ZKPBA protocol for enhancing web security, and my paper ID is 175. So this is a basic workflow of our like what we'll be discussing the things and what are the things we have followed. So firstly, how we came to this topic and what were our thought processes, like how we came to this and all that. So firstly, we identified that it's very important to like do a research that has some societal impact. And moreover, in order to contribute to a societal impact, we need to solve some real life problem. So we thought, let us restrict our domain to security and start solving some problem related to security. After having a thought, we did various literature review and we found out that the amount of cyber attacks has been increasing to a greater extent. The attacks that were happening in 2004 and the attack that were happening now are vast. Means every year the cyber attacks are increasing, and it's very important to preserve the information of the user or a patient or a like a app user or some it's very important to preserve the personal sensitive information. So what we thought that let us focus on a protocol or on a technological stack that solves this problem of having the data breaches. So we came up with this zero knowledge proof based web authentication protocol for this thing. Now, as I discussed the problem that like various kind of attacks, intruders try to manipulate various information of the legitimate user and try to use that data for the personal gain. So like it's very important to compare the traditional methods that were used earlier, the modern approach that are used now, and the approach that we have implemented that enhances both the approach. So like nowadays we have been using MFAs, biometric and PKI, all that approach. So what this approach has, like it has the data linked with it. So when we transmit the data in a transmission channel, the informations are shared through the channel. So we thought like if somehow the intruder tries to gain access to the system or tries to manipulate the thing, then the data will be leaked. So zero knowledge proof based web authentication, what does it do? It does not involve transmitting the sensitive information like password and all that thing through a channel. It just involve a challenge response cycle that a verifier and a client needs to follow in order to get authenticated. So by conducting a literature review, by analyzing various technologies that has been using nowadays, by enriching and referring various blogs, we came to this zero knowledge proof based web authentication. So now I'll be discussing the core crux of our protocol. So basically our protocol is divided into four phases. First one is a registration phase, second one is a commitment phase, third one is a challenge response phase, and fourth one is a verification phase. So these are the core crux that deals with the security enhancement and the security requirements for our protocol. So like this is whole the diagrammatic representation of our phases and the protocol. So I will start off with each and every phase and I'll explain each and every terminology shown in this figure in a detail. So firstly, the client will register himself or itself to a server via encrypted channel. Here, private key will be randomly generated, public key will be given, one generator polynomial that is a small prime number, and one modulus number that will be a large prime number that will be used. Public key will get splitted to a k servers. The public key which is splitted to a k server is then registered and the server will authenticate the registration process. And for each and every public like public key corresponding private key will be generated and the information will be sent to a server. The server will use that information and like will split and will share the further information to the k different server. So this is where the threshold cryptography comes into picture. So this was the registration phase. After registration phase, the second phase comes is the commitment phase. In commitment phase, like the overall authentication process got started, and like uh, one nonce, that is a random number, will be used in order to generate the commitment. That commitment will be sent to the server, and a raw response will be generated. After the raw response is generated, the challenge response cycle starts. What is this challenge response cycle is? Like in challenge response cycle, we have predefined certain challenge, and a game sort of thing between a client and verifier starts off. Like first process, the client will generate a response, and the verifier will then verify it. And if it passes all the challenges and the verifier gets the expected response, what it is expecting, then the authentication will be successful and user will able to authenticate it. So this was the crux protocol for the same. Now what we concluded with the result and analysis section, that we'll be discussing in a short. So firstly, we performed a crypt analysis, and there we have used a discrete log, that we have tried to identify a discrete logarithmic problem. Like we have used a greater modulus value and a smaller generator value, which make our protocol prone to brute force attack and dictionary attack. The secondly, we have used threshold cryptography, which distributes the keys among k server. So like it promotes decentralization. So if one server, or if there is a single point of failure, then also whole private key will not be available to the intruder or the attacker. The second thing which we have, like the vulnerabilities which we have mitigated through this are like earlier replay attacks where possible, as we have created unique nonce for each and every session. So this replay attack is mitigated by that. The distribution of private key among k servers enhances the security, as the intruder will not able to expose the key by combining all the rest keys. And the second thing is like
Excuse me, sir.
the risk of, yes.
Yes, sir. You have 1 minute of time left. You will have to conclude in the given time frame.
Okay, okay, okay.
Yes.
And the performance that we have found after implementing this, the performance which we found out that uh, the total or overall computational complexity depends on the challenge response cycles. If there are more challenges, then like the security will be enhanced and performance will be therefore optimized. So this was our performance analysis, and this is a conclusion. Like this way, zero knowledge proof enhances the security, and it prevents various sort of attacks by implementing threshold cryptography. Moreover, in the future work, we can focus on optimizing the servers, optimizing the usage of resources and storage of private key. Thank you so much. Any questions?
Yeah, so I just have some questions.
Yes,
So first,
yes, sir.
there is your application online that I can access it publicly.
Yes, this ZKPVA is basically used for password login, for like automatic authentication of IoT devices, and for like in highly riskful task, if we want a secure access, then like for government agency and all that, we can implement this protocol.
So currently, it's just like we are developing, and it was in public. I mean, does it launch into the real world application?
Yes, the researchers have performed various analysis, and like this is the emerging technology. So like still the companies and the research community is implementing and performing research on this. After certain advancement, like it will be implemented to a real life web application in order to enhance the security.
Thank you for your answer.
Thank you so much, sir. Any more questions?
None. So maybe we can turn to the next presentation.
Okay,
Thank you.
so
Thank you.
as there are no further questions or suggestions, thank you, sir, for your presentation. We'll move towards our next presentation. Our next presenter is Santoshini R, who will be presenting a paper on an ensemble approach for tuberculosis detection using bronchoscopy diagnosis in conv- convolutional neural network and residual networks through feature fusion. Ma'am, are you in the session? Santoshini, ma'am?
Audible?
Yes, ma'am. You are.
Hello. So my screen is shared. Sir, is my screen is shared?
Yes, ma'am. Yes, ma'am. Your screen is shared. You are audible. You may proceed with your presentation.
Okay, okay, sir. Good morning, everyone. I'm Santoshni, and my paper ID is 97, and my paper title is An Ensemble Approaches for Tuberculosis Detection Using Bronchoscopic Diagnosis and CNN and ResNet through the Future Fusion. And this is my presentation framework. This is all of my presentation framework, and this is my abstract. My paper is discussing about the tuberculosis. The tuberculosis is a predominant and potential life-threatening infectious disease. And the tuberculosis is a chronic infectious disease caused by the Mycobacterium tuberculosis, and it is affects the lungs, but it also an impact other parts of the body such as brain, spine, kidney, and lymph nodes. For detecting and diagnostic and therapeutics are there for detecting a TB. There are predictable traditional diagnostic methods are there. Sputum microscopic methods, cultures, they are time consuming and less sensitive, often limited by the human expertise. The bronchoscopic or an automated tool capable of enhancing the precious efficiency of tuberculosis diagnosis. And the model begins with the pre-processing of bronchoscopic image, fetches into the CNN and ResNet by combining the both models to extracting the features network to capturing the informatic and improved classification accuracy. The future begins to classify the tuberculosis, whether it is in TB or not. For my ultimate goal is to capture the reliability and precision of TB detection, addressing the challenges by variability of bronchoscopic diagnosis of more constant and accurate. The experimental results of imaging datasets in individual models in terms of accuracy, recall, and F1 score precisions. This highlights the potential of combining the deep learning models to assess the radiological equipments of detecting the tuberculosis through um, bronchoscopic contributions of infectious disease management. And this is my introduction of tuberculosis. Tuberculosis is the most leading reality worldwide, particularly in the region of limited access of health care. So the bronchoscopic examination is followed by the procedure to then radiological equipment by diagnosing for preventing the TB in the lung. By performing the bronchoscopic, the doctors are making immediately visualize the which area is affected and how it is affected. Because the taking a biopsies or some other, it can be uncontrollable bleedings, and it affects the tissues of over there. Here we are in this paper I'm talking about the picking up the image and processing the these are all the World Health Organization status of tuberculosis. The tuberculosis is a critical issues of 8 millions of falling illness in 2023, slightly increasing through the previous years. Approximately 1.2 millions of people have been died, the TB including the 6 lakhs people. This makes the leading death of an infectious disease in the COVID recent years. The global incidence and reliability rates and region breakdowns of an TB detections. These are all my literature survey which have been read by me. This literature survey which have been read, there are limited assets of bronchoscopic overall appearance. There are rarer than the specific characters specifically accurately classifying the tuberculosis are identifies the pattern necessary for precision detections. The overall appearance that extracting the futures are lesser in that most of the papers. So these are all the advantages and limitations and technique has been used in that literature papers. And these are all my research gap and identifications, which have been the contributions I have did. The gap in this research, the insufficient scopus focus on future fusion in the TB detections, and limited data for training a bronchoscopic and computer-aided diagnosis system, lack of comprehensive and simple models combining ResNet and CNN. The less explored for TB detection in bronchoscopic. And then invisible nature of invasive nature of procedure, the lack of automated tools are specifically designed for analysis. My contribution of the project to develop the combining approaches to incorporate the output model, reducing the misclassification and strengthen the model. And this is my workflow. I'm sorry. This is my workflow. The input image which have been taken from the data set, relatively a small data set addressed by
Excuse me,
overfitting
ma'am.
or sir.
Ma'am, you have 2 minutes of time left. Please conclude your presentation within the given time frame.
Okay, so sorry. And then this is my pre-processing, and the data sets have been pre-processed and pre-sizes and color conversions. And after pre-processing my data, and then we moved into the CNN and ResNet models, and the CNN and ResNet models as for convolutional layer, max pooling layer, and fully connected layers. These layers has for the deep learning models to particularly specified suited for the image processing tasks. For applying a filter small regions and then input images for a horizontal output, and then activation functions for learning a complex models, and then pooling layers for future mappings, and fully connected for classification tasks. Here I am using the ResNet models for residual connection for training the process. Each block consists of two convolution layers with residual connection, and skipping connections for input to each residual blocks is added to the output blocks, and combining both extract the spatial features from the bronchoscopic image, extracting the temporal features from the sequential feature data, combining both for concatenation mechanisms. This is my binary classifications. Binary classification task. I'm using a logistic regression and add a optimal directed output for fitting the correct accuracy rate. And here I have collected my data sets from Vietnam, by hospital in Vietnam. And these are my data set sample and the normal and abnormal image. And the convolutional means for processing and models which have been I have worked on it. And then since an architecture and the ResNet architectures over here. And then the fusion of CNN and ResNet, here I'm flattened the both the layer, and then I have classified by sigmoid classification method, and can get my model test, and then the evaluation matrix is over here. These are the result analysis which I have gotten high level and low level of my accuracy. And these are the confusion matrix and the classification matrix of my discussion with me. And the comparison analysis existing diagnostic methods over here. And my conclusion is to that the categorical cross entropy analysis of the model to strengthen the classification and adopt to accuracy epoch to then increase my future extraction capabilities. And these are all my future work to expand the improve the data sets and my reference. Thank you.
Okay, so
So,
thank you for your presentation, Miss Santosini, all right. So you're currently student, right? Sorry, you are currently student, are you?
so I'm PG student.
Yeah,
I'm
yeah.
a biomedical, a
Um,
master's.
yes, thank you. So I just have some consideration, like some suggestion for the next present, maybe better for the next time. And the problem is that your research is good and have a good results, but actually your presentation is pay more so much attention to the literature review and the introduction, and you don't pay more attention to your methodologies and also your results. So that's why you are losing the time. So next time you just go quickly about the abstract introductions and related works, and you just go directly to the problem that you're doing, right? And I mean,
Sure, sir. I
yeah,
will manage my time. Yeah, sure, sir. I didn't manage my time. This is my fault. I will learn it, sir.
yeah. Don't worry. So yeah, I think that will be better for the next time. And this good. Your research is have a good results, and you can apply for the medical AI, right? So that's really good. Really good point. So that's just my some of my suggestion.
Thank you. Sir.
Thank
Thank
you.
you so much.
Yeah.
Thank you, ma'am. So we'll move
Thank you, sir.
towards our next presentation. Our next presenter is Melvin A. Gomez, who will be presenting his paper on autonomic service mesh using machine learning operations.
Hey,
Mr.
hello.
Melvin, are you in the session?
Yes, I am. Am I audible?
Yes, sir, you're audible.
Okay. Give me one sec. Um, it's asking me to. Are you guys able to
Mr.
see your
Melvin,
screen?
are you facing any technical issues?
Yeah.
Uh, we'll do one thing. You just ping me in the chat box regarding your issue. We'll move towards our next presentation. We'll take your
Sure.
presentation later.
Okay.
Yeah. So our next presentation is Kothai Suresh, Shri Suresh, who will be presenting a paper on Benembot. So, ma'am, are you present in the session? Any co-authors associated to this paper in the session? We'll move towards our next presenter. Shlok Belgamwa will be presenting its paper on democratizing medical imaging, knowledge distillation for lightweight multi-level AI models. Mr. Shlok, are you in the session?
Yes, I am in the session. I'll just share my screen.
Sure.
My screen visible?
Yes, sir. Your screen is visible and you are audible. You may proceed with your presentation.
So good afternoon, everyone. I'm Shlok Belgamar from the Pune Institute of Computer Technology. Today, I'll be presenting our proposed framework for democratizing AI in medical imaging. This work outlines a conceptual approach aimed at overcoming the challenges of deploying high-performing ensemble-based models in resource-limited settings using knowledge distillation. My paper ID is 62. Yeah. So AI has significantly improved disease detection in medical imaging, but many of these high-performing models rely on computationally heavy ensembles. This makes them difficult to deploy in environments such as rural clinics or mobile health units. The motivation of this research is to propose a framework that reduces computational demands while aiming to preserve diagnostic accuracy, thereby making advanced diagnostics more accessible in low resource settings such as rural clinics or mobile health units. A little bit of introduction and background. The challenge lies in the heavy computational resources required by ensemble models. So our proposal leverages knowledge distillation, a method to conceptually transfer the knowledge from a complex teacher model to a lighter student model. The key question we explore is whether this conceptual approach can significantly lower computational costs while retaining high diagnostic performance. Some related work. Existing research shows that ensemble learning can boost performance by combining different architectures, and knowledge distillation has been effective in other domains. However, the specific application of these methods to multi-label medical imaging, where multiple diseases may coexist, remains underexplored. Our proposed framework aims to fill this gap by outlining a strategy that could enable efficient deployment in real-world clinical settings. So our basic methodology or the proposed teacher and student models are uh, a conceptual teacher model formed by ensembling ResNet 50, DenseNet 121, and EfficientNet B0. Although such an ensemble is powerful, it is also resource intensive. We then outline how knowledge distillation can be used to transfer this expertise to a lightweight student model, MobileNet V3 Small. In our conceptual framework, the teacher produces soft labels to guide the student's learning process with temperature scaling, ensuring a smooth transfer of information. In this example of our research, we tried our framework proposes the integration of the three key data sets: NIH chest X-ray, Mimic CXR, and CheckSpurt. Each data set brings unique strengths in terms of scale, clinical context, and label handling. In our conceptual approach, all images would be resized to 224 by 224 pixels, normalized using ImageNet statistics, and processed with weighted sampling to mitigate class imbalance. This integration is crucial to ensure the model is robust and generalizes well across different scenarios. We also integrated explainability in this research, or we proposed integrating explainability in this research. An essential component of our proposed framework is the incorporation of explainability and ethical considerations. We propose using techniques like GradCam, which could provide visual explanations by highlighting the regions of an image that influence predictions, and SHAP, which quantifies the contribution of features. Additionally, our framework stresses the need for fairness, bias mitigation, and data privacy throughout the model development and deployment process. Additionally, GradCam would help the doctors in rural or in any setting understand why a particular decision by the AI model was made. So the main crux of the paper, or the main aim of the paper, was to address challenges of deploying AI on edge devices. So in this example or this concept, we discussed on how this can be implemented on Raspberry Pi or NVIDIA Jetson Nano, which have limited resources. In our conceptual framework, we suggest using techniques like quantization-aware training and model pruning to optimize the student model, reducing both its size and computational requirements, thereby making real-time diagnostics feasible on these devices. So the projected performance based on the benchmark studies and conceptual analysis The teacher model is expected to achieve an OROC score of around 0.92. After applying knowledge distillation, the student model is projected to retain about 95% of that performance. That is approximately 0.90 OROC, while reducing computational costs by roughly 75 to 80%. These projections suggest that our framework could potentially enable high performance diagnostics on resource constrained devices. This would enable real-time diagnostic with the application real-time diagnostic application of such AI with limited resources. In conclusion, our proposed frameworks offers a conceptual pathway to achieving efficient, high-performance AI for medical imaging in low-resource environments. While our work is currently a proposal, it lays the groundwork for future empirical studies and real-world validations. Future research will focus on implementing this framework on actual devices, refining multi-label classification methods, and further enhancing fairness and bias mitigation strategies. We believe this approach can significantly democratize access to advanced AI diagnostics. So that is it with my presentation. Any questions or suggestions? Be good.
Session chair,
Thank you
are
for
there any
your
questions from your side?
yeah. Thank you for your first of all, thank you for your presentation. It's a inspiring inspiration. And can you share with us a little bit about how that you can collect the data set? As I know that the medical data set is really difficult to collect due to the problem with publicity. So can you share with us a little bit?
So there are many open source data sets currently available, such as NIH chest X-ray dataset, on which I'm currently working to develop this model, which I've discussed in this paper. So we can train the model on such data sets which are openly available, which also have integrated some disease predictions already into it. And once such training is done on the teacher model, we can transfer this teacher model learning into the student model, which would be a lightweight model, essentially.
Yeah, thank you. So that's it for my question. Thank you.
Thanks a lot, sir.
Okay, so are there any questions or suggestions for this paper? I see, so there aren't any further questions. So thank you, sir, for your presentation. We'll move towards our next presenter.
Thank you so much.
Yeah. So our next presenter is Melvin A. Gomez, who will be presenting his paper on autonomic service mesh using machine learning operations.
Can you guys see my screen?
Yes, sir, your screen is visible and you're audible.
Okay. Good morning, afternoon, everyone. My name is Melvin Gomez. I'm a student from PES University, currently pursuing my BTech degree in computer science and engineering. I'm delighted to be here today for this ICTIS conference and excited to present the project that me and my team have been working on, which is the autonomic service mesh using machine learning operations. My paper ID is 156. Okay. This is the roadmap that I'll be going through. Introduction. In today's distributed systems, DevOps engineers and site reliability engineers will manage multiple microservices spanning across multiple different Kubernetes clusters. SREs, site reliability engineers, must use service mesh technologies such as Istio to manage and load balance the traffic between microservices, enforce security policies, and respond to failures and make control changes in the service mesh. SREs manage the service mesh using policies defined using YAML files. This approach lacks real-time insights from the service mesh. It's dependent on human intervention and it is error-prone. The goal is to automate the service mesh management using machine learning. Our system monitors the services in real time, learns continuously, and makes autonomous changes to respond to the changes in the service mesh or prevent issues, all without human intervention. Autonomous in this context means that the system independently detects anomalies or issues, decides on the appropriate course of action, and implements changes automatically, all based on learned patterns and pre-configured policies without the need for manual oversight. Let's go to the technical approach. So we first divide the enterprise application into separate service domains or traffic zones. We set up an MLOps pipeline per domain to deploy the machine learning models for anomaly detection. Then we configure the service mesh manager in each domain to react to the anomalies and trigger actuations. On here we call the actions. SRE engineers review these past actions or actuations and give feedback through the ratings or scores. The machine learning model performance is assessed and using both metrics and the SRE's feedback. And then we promote new machine learning model versions to production based on the performance. We can go through the architecture. This is like a high level architecture of the project. The data collector is used to collect the data and store it in the database. Alongside, it will send the data to the model running in production. The data collected from the database will be used in the pipeline to train the anomaly detection model. The model is moved through the pipeline and finally goes to the production environment where real-time data is fed to the model and the model detects the anomaly events. These anomaly events are then sent to the service mesh manager to autonomously choose an action based on the anomaly events. These actuations are changes to the STO policies. So we go to the implementation. So first we partition the services, logically partition the enterprise application into multiple different service domains. Each service domain forms a traffic zone within which are different interconnected microservices. For example, a front-end zone, back-end zone, or a critical path. Then we collect the telemetry. The metric collection is we use Istio observability as well as Prometheus to collect the following HTTP traffic metrics for all nodes and edges in the service mesh, like Istio request total is one of the parameters that we collected. Then we build a data set from the data that we've collected, and we use Locust to generate the synthetic load for the enterprise application to simulate the normal and anomalous traffic patterns. We deploy the machine learning models. So an anomaly detection machine learning model is deployed in production for each service domain, supported by the MLOps pipeline with training, pre-production and production stages. In the training stage, historical data is used to test the models and the best ones are promoted. These are then evaluated on real-time data in pre-production stage with an accuracy and anomaly displayed on the SMM dashboard. The top performing models is deployed to production where it detects the anomalies in real time and triggers corrective or preventive actions to the service mesh manager. Next, we will be doing the service mesh manager where the service mesh manager follows an event condition action workflow. It gathers this data, telemetry data, including affected microservices and its neighbors, the existing Istio YAML configurations, historical YAML policy changes, and the feedback, as well as the anomaly event that was raised from the machine learning model. And it triggers an actuation or changes in the YAML file if the conditions are met. Next, the continuous feedback. As I said, the DevOps engineers provide feedback on the machine learning models. Essentially, the whole outcome of this is to improve the machine learning models and improve the automation script and enhance the self-healing capabilities. The results. Okay. The framework was tested on a Bookinfo application using Locust for traffic simulation and anomaly detection models for threshold anomaly and trend anomaly models, which I'll be talking about a little bit later, which achieved a 90% accuracy. The service mesh manager autonomously applied a corrective action based on the anomalies that were detected. The threshold anomaly detection model, the model that we use was the SURI Max model with dynamic thresholds to detect the anomalies. The anomalies are raised by the SURI Max model that you can be seen in the diagram over here. And a circuit breaking actuation was applied in the service mesh manager, halting the traffic during load spikes that exceeded these dynamic thresholds, preventing failures and ensuring service stability. Then the trend anomaly model.
Excuse me, sir.
Yeah.
So you have 1 minute of time left. Please
Okay.
conclude your presentation within that given time frame.
Sure. The model we used was the Facebook profit model to detect traffic. Here we have, there was multiple different versions of the reviews services, which was like V1, V2, and V3. And the SMM generated a YAML file, as you can see down here, where the initial configuration was 50, 25, 25, and the version affected was version 1, and it applied the YAML file where it made the rerouted the traffic to 0, 50, and 50 to prevent failures, server-side failures, and improving the fault tolerance. The MLOps pipeline, as you can see, has multiple different stages. The MLOps pipeline ensured seamless model retraining and deployment by continuously incorporating new traffic data. The pipeline ensures the anomaly detection models maintain a high accuracy. The conclusion. Okay. The project describes a method and implementation for autonomic service mesh manager using machine learning operation pipeline and production environment. It eliminates the need for uncontrolled macro level changes to the service mesh. Instead, it proposes and proves an ability to implement granular autonomic response in the service domain or traffic zones. It uses localized anomaly detectors in the traffic and resource utilization metrics to take preventive actions instead of waiting for the real-time failures using machine learning models. It's adaptive and continuous. It adapts and continuously evolves with changes in the service mesh and IT environment using the MLOps workflow. It implements. It has the whole framework implements a collaboration between the data scientist, machine learning engineers, machine learning operation engineers, and DevOps engineers. The autonomic service mesh manager efficiently manages and optimize the application traffic within distributed systems, thereby improving the performance, reliability, scalability, while reducing operational overhead and manual intervention. For the future work, we would firstly like to look at different other service mesh technology and other data sources that can be used to manage the following aspect of the enterprise application: capacity, security, throughput, cost of ownership, and energy efficiency, and also different other anomaly detection algorithms. So different machine learning algorithms to improve the anomaly detection. And yeah, I would like to say thank you for your time. I hope you found the presentation insightful. I like to extend my gratitude to the organizers of ICTIS conference for providing this wonderful opportunity. Thank you all, and I hope you enjoy the rest of the conference. Any questions?
Thank you, Mr. Gomez, and for your presentation. Just to conclude and clarify the problem that you've been doing. So what are the main challenges of deploying machine learning operations in production environments, and also how does machine learning helps automate service management?
So the reason why we had introduced the pipeline, it was because the whole point of microservices, it constantly keeps evolving. New microservices come in and new ones go out, old one might go out. The connections, how the connections flow through the microservices constantly keep changing. So having one single machine learning algorithm that is trained on old data will not perform as well as someone who's trained some machine learning algorithm trained on newer data. So having a pipeline to continuously keep training the model is the reason why we implemented this MLOps pipeline. And machine learning, how does it automate it? It essentially, right now is we have to manually observe these Istio configurations, and any anomaly that we observe, we have to go and write a YAML policy and change it on our own. So what we are doing here is a machine learning algorithm to detect the anomalies, send it to the service mesh manager, which is used to generate these YAML files and also used to update the values in the YAML files, and then it applies the YAML files. So that's how we are essentially automating it.
Thank you for your answer.
Thank you. Thank you so much.
That is one question. That's it.
Are there any further questions or suggestions from other authors? If no, we'll move forward with the session. Thank you, sir, for your presentation.
Thank you, everyone.
Our next presentation will be Kotai Sri Suresh. Will be presenting a paper on Benbot. So, ma'am, are you there in the session?
Yes, ma'am.
Okay, so ma'am, are you ready for the presentation? We'll begin immediately.
Yes, sir, will present.
Okay, you may begin with your presentation.
Hello,
Yeah, you can
Yes, ma'am,
start.
you're audible.
everyone. Our project titled as Bangkok.
I think that she
Slide.
lost her connection.
Ma'am, are you facing any technical issues or internet connectivity issues? Any of the authors or co-authors of this paper, are you facing any technical issues?
These are the synopsis of our project. Next slide.
Excuse me, ma'am. Maybe there's some problem with your microphone. I think so.
Yes, I'll look into it. Raga Malika ma'am, are you facing any internet connectivity issues or any technical issues with your mic because you are not audible? We are only able to see the changing slides on the screen.
For a while, or I'll present the next, sir.
Hello, am I audible? Ma'am, if you are facing any technical issues or internet connectivity issues, we can take your presentation later. Just ping me in the chat box regarding your issue and we'll resolve it. Till then, we'll move towards our next presentation. Our next presenter is Nagarjun E, who will be presenting his paper on fog resource allocation and reallocation for IoT tasks using multi-object Osprey optimization algorithm.
Yeah,
Nagarjuna, sir, are you in the meeting?
yeah. Thank you, Adish.
Okay, so you may proceed with your presentation.
Is my screen visible now?
Yes, sir, it's visible.
Yeah. So, hi everyone. My name is Nagarjun and I'm from Bangalore University. I'll be presenting the paper entitled Fog Resource Allocation. Sorry. Yeah. So I'll be presenting the paper entitled Fog Resource Allocation and Reallocation for IoT tasks is 89. And this is the outline for the today's presentation. Like I'll start with the introduction, motivation, and then I'll conclude the proposed work and I'll display some references. So coming to the introduction, so as we know, the rapid growth of IoT devices has led to a significant surge in the volume and rate of data generation. And to process this huge amount of data on cloud may not be an expeditious solution. And to overcome the and also to the with the limitations of existing cloud computing like latency, delay, and cost. So Cisco has introduced the fog computing in 2012, to extend the computational capabilities of cloud computing. Basically, the fog computing provides the efficient data processing and storage closer to the data sources and end users. So with this, we can reduce the limitation. With this, we can reduce the latency and also the delay and also the cost. So with this introduction and motivation is motivation. So based on the existing literature survey and the existing works, a critical challenge is how to select the fog nodes, because the fog nodes will have the limited capabilities when compared to the cloud computing. So with this limitation, in order to maximize the fog resource utilization and minimizing the response time and the completion time and also the execution time while satisfying the QoS requirements of the application is challenging in the fog computing. So that is the motivation. And coming to the contribution, we have proposed the meta-heuristic multi-objective Osprey optimization algorithm for Thailand for multi-objective IoT task allocation in fog computing environments. And we also implemented this algorithm in the iFog simulator and evaluated its performance against genetic algorithm and PSO algorithm by varying the number of IoT tasks and exploring with the different parameters. And the results demonstrated a significant reduction in average response time, execution time, and completion time, showcasing the efficiency of our proposed approach. And coming to the literature survey, so due to the limitation, I have added only 4 papers in the literature survey. The first author, Bandopadhyay, has introduced the game theoretic model for resource allocation and dynamic pricing in fog computing. The advantage of this model is that it efficiently utilizes the resources through non-cooperative computation and dynamic pricing and improves the system performance. And it also offers flexibility for users with completion time issues. However, the metrics such as response time and execution time of task is not addressed in the work. And Nagarjun A, it's one of my paper. We have proposed the agent-based resource allocation using contract net protocol to dynamically map tasks to the virtual machines based on the resource availability and task requirements. And this approach, we have reduced the network usage, loop delays, and energy consumption. However, metrics such as task completion, response time, and execution time were not addressed in this work. And Ajam at all, they have developed a spider monkey optimization algorithm for task scheduling and resource allocation in fog computing. And the advantage of this algorithm is it minimizes the total cost in monetary cost and also the service time by selecting the optimal fog nodes for task execution. However, this work also not address the parameters like response time and task completion time. And Jabber at all, they have introduced the particle swarm optimization algorithm to optimize the network resource management to minimize the latency and power consumption. Basically, the advantage of this work is they have minimized the power consumption and also the latency. But the key metrics such as response time, task completion time, and execution time remains unaddressed. So with this literature survey, we came up with the following problem statement and objectives. The problem statement is given an application comprising a set of n independent tasks and given a set of m fog nodes. The problem is to determine the task to fog mapping with the following objectives. And the objectives of our work is minimizing the completion time for processing the IoT task, minimizing the response time for IoT tasks, and also minimizing the execution time for IoT tasks. So with this problem statement and objective, we came up with the proposed work. So basically in the proposed work, we efficiently identify and allocate the resources to minimize response time, execution time, completion time, and balance the load among fog nodes. So basically we have used the algorithm called Osprey optimization algorithm. So I'll just provide the overview of the Osprey optimization algorithm. So basically, Osprey optimization algorithm is inspired by the hunting and behavior patterns of the osprey, bird of prey that primarily feeds on fish, known for its sharp vision and specialized hunting strategy. So the osprey locates fish underwater from a height of 10 to 40 meters before diving to capture them. After catching its prey, the osprey takes it to a safe location to consume it. So this natural behavior marked by precision and efficiency forms the basis of the Osprey optimization algorithm. So in the context of fog computing, we have adopted this Osprey optimization algorithm to allocate and reallocate the resources efficiently among tasks and fog nodes. So basically, we have utilized the three-layer architecture where you can see this proposed model. So in the proposed model, like we have three-layer architecture where the first layer or end layer is called an IoT layer. In the IoT layer, we have placed the IoT devices, and the second layer, which is called as a fog layer, where the tasks will be allocated by using the multi-objective Osprey optimization algorithm. And the cloud layer is like whenever the fog nodes are not available, in that scenario, the task will be directly forwarded to the cloud layer for processing. So I'll be explaining how this MOOA works, right? So basically, our multi-objective Osprey optimization algorithm will work in the two phases. The first phase is identification and resource allocation, and the second phase is resource reallocation. So this is the algorithm. So basically, the algorithm takes the input as number of tasks, number of fog nodes, and the population size, and maximum iteration size, and objective function. So here, the population size we have considered as 30 after doing some random testing and everything. Like we have considered population size to 30 and maximum iteration we have took as 100. And the objective function are response time, completion time, and yeah, and the output would be the optimized task to fog node mapping. So the in the initialization phase, the it generates randomly n number of solutions. Here it's like 30 ospreys, and then it evaluates the fitness of each solution using the objective function, which is the objective function is nothing but response time and completion time, right? And in the phase one, it identifies the
Excuse
resources.
me, sir.
Yeah.
So I request you to conclude your presentation in coming 2 minutes.
Sure. Yeah. So this is the overall algorithm. So in the first phase, like it allocates the best position, and if the position is okay, then it will not check for phase two. And if there is any like a resource fluctuation, then it moves to the resource allocation phase, and it will check for the whether there is any change in the resources. If there is any changes, the resources will be reallocated, and then the final solution will be found, and the final like optimized task to fog node mapping will be done. So this is the overall algorithm. And coming to the results and discussion, like we have used the IFOC simulator, and these are the parameters which we have considered in the simulation. And coming to the response time of task, like we have considered 50 fog nodes for the simulation and varying number of tasks. So you can see here, like the response time in the proposed work is decreased when compared with the genetic algorithm and particle swarm optimization. And coming to the execution time as well. So you can see that proposed algorithm is like comparatively decreased when compared with PSO and genetic algorithm. Same way for completion time as well. So coming to the conclusion, so we have proposed a multi-objective optimization algorithm aimed at optimizing resource allocation and reallocation in fog computing environments for IoT tasks. So by optimizing multiple objectives such as completion time, response time, and execution time, MOA provides an efficient solution for managing fog resources in dynamic and resource constrained environments. And also the comparatively, yeah, like comparing with the existing algorithms, our algorithm improved in the execution time and response time, and also the completion time. And in the future work, like we will be focusing on extending this approach to incorporate energy efficiency, fault tolerance, and other multi-objective optimization to address diverse quality of service requirements in the dynamic fog computing environments. So these are some of the references. And thank you. Like, is there any questions?
Thank you so much for your presentation. And among the performance metrics you use, response time, execution time, and completion time. So which ones are the most improvement with your proposed approach?
So when compared with existing algorithms in all the three, like our proposed work has been better.
Thank you for your answer.
Yeah. Thank you.
Are there any further questions or suggestions for the paper? If no, then we'll move forward with our next presentation. Our next presenter is Mr. Nachiket Deshpande, who will be presenting his paper on Gen AI Smart Assistant. Sir, are you in the session?
Yes, I am.
Okay, so you may proceed with your presentation.
Is my screen visible to you?
Yes, sir, your screen is visible.
Thank you very much. So the title of this presentation is Gen AI Smart Assistant. The paper ID is 166, and I have also mentioned about the co-authors of mine. So let me first of all tell you about the abstract of the paper. The Gen AI Smart Assistant, which is an advanced AI-driven platform designed to improve productivity and simplify tasks for businesses, NGOs, and individual factors. It is a completely AI-driven productivity platform which is targeted for NGOs, small businesses, startups, and other such units. It has majorly two main components: AI productivity tools and AI for business components. It consists of various modules like document generation, code generation, image generation, music generation, video generation, conversation, and spreadsheet analysis. Now, while introducing this paper, I would like to tell you that this is a completely AI-driven productivity platform which has an automation of automating repetitive tasks like document creation, programming, coding, content generation, and all. Target users for this is small, as I mentioned, small businesses, NGOs. What makes this Gen AI Smart Assistant a key factor? What differentiates us is it is more affordable, more accessible, and most importantly, all in one combined together. The technological backbone is obviously machine learning and NLP models. The main agenda of the Gen AI Smart Assistant project is to create unified AI platforms that enhances productivity and meets growing demands of business firms. That is to streamline productivity tools, um, increase the ease of work, specifically designed for businesses which are not that technically sound, and also to differentiate from traditional tools that are not very much affordable, that do not use Gen AI or do not offer everything in all such combined. Now, while telling about the literature review, there exist certain tools such as Google Workspace with AI features, Microsoft Copilot. Google Workspace offers you auto completion, summarization, image generation, but fails to offer other tools such as video generation and all. Microsoft Copilot is for task automation, document assistance, and but it somewhere lags in code generation. Notion like AI is considered to be one of the best for document generation and document generation and for your conversation modules. But what all these combined lack is uh, they lack somewhere that they do not hold everything in themselves. They are individual module setup, not tightly coupled with each other. As I mentioned, we have studied Microsoft 365 in detail, Google Workspace, generative AI tools, and we have also gone through certain research papers, such as what I have mentioned in Devarajan, that when we use GitHub Copilot, it does not offer you very much uh, corrections and creates issues like plagiarism and accuracy for students. Now, about telling about the literature review, informed development, novel. We have studied novel as such. The module which we used for integrating our document generation and our
email addition, everything like that. Another thing which we used is Copilot Kit. Copilot Kit is a module which we used for integrating our spreadsheet analysis module and such similar platforms. It is, after all, an enhanced, affordable, and AI-powered tool. We have used creative AI tools for AI image generation, text generation, music generation, code generation, user-centric design built for simplicity and speed. Now, let me drive you through the technological overview. Front-end architecture. The front end is built with TypeScript and Next.js, ensuring type safety, server-side rendering, static generation for better performance and SEOs. Tailwind CSS provides a streamlined, consistent. What we have used is hooks and context APIs. Interaction are handled using Axios and Fetch APIs. Backend architecture is nothing but Next.js API routes using Azure SDKs. We have used Azure OpenAI keys for connecting with the backend and using cloud-based service models. Replicate AI supports multiple image generations, video generations, and all. For all this, we have used a Clark for authentication, which offers you authentication of user. Now, cloud services integration, as I told, we have used Azure load balancers, which balance the load, and Azure API management, which offers API keys in return, Azure API keys in return, which connect us to the backend and cloud networks. The deployment strategy. Deployment is offered on Vercel, which is offering us a seamless integration with Next.js and the ability to handle serverless functions efficiently. It simplifies our deployment. Now, while tailing, I just mentioned that we used ML-powered modules for NLPs, GANs, code generations. For code generations, conversations, we use Azure OpenAI keys. For image generation, video generation, and music generation, what we used was Replicate AI. For content generation, the Novel SH module was integrated, which is a Notion-like AI. Similarly, for spreadsheet analysis, that is for Excel, we use a Copilot Kit. We have used a lot of documentation, a lot of research papers about GitHub, about Python code generation, and accuracy in that. This is a modular architecture of ours. When a user logs into our portal or signs up into it, he or she finds a dashboard with productivity tools such as AI Sheets and AI Docs, AI Chat, code generation, music generation, image generation. After all, there is a content generation one, and you can export and share your findings, export and share your work along with your teammates in a peer-to-peer connection. Now, as I told, the tech stack for was Azure API keys, Replicate, Copilot Kit for spreadsheet analysis, and Novel.sh for document generations. The best feature of this platform is it is all modules unified for smooth collaborative user experience. All in one integrated platform which makes us different from all other existing platforms and gives us an advantage over them. Now, at last, I would like to showcase some of the results of our project. See, like the conversation module, we type our prompt onto it. After a prompt onto it, and we generate results out of it. The code generation module is a vital component. The code generation module gives us the code of what we have suggested. A spreadsheet analysis module, which uses an Azure API key along with the Copilot Kit, gives us a complete leveraging access to spreadsheet analysis and other mathematical calculations. And at the last, I have Gen AI based module, or like similar to Notion like AI, based upon Novel SH integration for writing, editing, grammar, and task management. It provides several use cases such as to-do list, improving grammar, making shortening, largening of the text, fixing the grammar, and everything combined into one module. So this is the conclusion of our project or the research paper of Gen AI Smart Assistant, which in itself is a unified platform combining productivity and creativity tools like AI-powered docs, sheets, and media generations built on a scalable tech of Next.js, Azure OpenAI, Replicate, OAuth, Clark, and after all, it is to boost efficiency, support users, and provide NGOs, small businesses, startups with all-in-one unified solutions. These are the references I have used and research papers which we have gone through. You can see it in the research paper as well. And at last, I would like to thank you all for your patient listening to the presentation. Thank you very much.
Thank you for the interesting presentation. Do you have any demonstration real time?
Yes, we have deployed it on the virtual app.
Yeah, so now I can access this.
Would you like? Yes, I would share the link of it in the chat box.
Yes, thank you.
You can access it through that. Any further questions, sir?
Yeah, that's it. Thank you.
Thank you very much.
Okay, so are there any further questions or suggestions from other authors? If no, we'll move towards our next presentation. Thank you, sir, for your presentation.
Thank you very much.
Yes. So our next presentation will be Kotai Sri Suresh, who will be presenting a paper on Benbot. Ma'am, are you ready?
Yes, sir. Am I audible?
Yes, ma'am, you're audible.
Visible, sir?
Mr. Just a second, ma'am. Mr. Nachiket, I request you to stop your screen sharing.
In the set time.
Hello, ma'am. I think your mic is muted.
Yes, sir.
Yeah. Can you please begin your session because we have sessions to take after this.
Okay.
Yeah.
Is my screen visible, sir?
Yes, ma'am. Your screen is visible and you're audible. You can start your presentation.
Okay, sir. Thank you so much. Good afternoon to all. I'm Rag Malika from SDNB Vaishnav College. These are my synopsis of the day. And the abstract of our project is this Benbot project focuses on Am I audible, sir?
Yes, ma'am. You're audible. You may proceed with your presentation. If there's
Thank you
any
so
issue
much.
from your side, I'll let you know.
Okay, sir. Thank you. The Benbot project actually is focuses on studying existing and segregation things. And Benbot aims to automate the process of sorting recyclable, non-recyclable materials at the resource, and it's easily for accuracy and communication. And this is our literacy survey. This survey is basically done for the knowledge, current statement of the knowledge, and the Benbot is designed to collect the solid waste at public places and residential areas. Our robot is designed with the programmed route, so it can navigate on its own. Next is how it handles the solid multiple waste. How nowadays solid multiple waste is increasing. So we have designed this to get rid of this problem. And it's an underground breaking solution to transform waste collection and processing. This is a traditional method, but our Benbot project operates in real time to collect and separate waste more than supporting more sustainable practices. Our goal of this project is a robotic machine that automatically handles waste right from the source, and we have integrated advanced sensor technology like AI, IoT, and robotics. Next, these are the methods which we have implemented. First is sensor collection. In sensor collection, we have to get the appropriate sensors related to our like necessary things. First, the sensor collection, and next is sensor integration. What are the sensors that we have chosen? We have to integrate all the sensors according to the structure and design of ours. Next is sensor calibration. We have to, the real-time monitor data and sensor readings must be collected. That's what happens in sensor calibration. Next is data acquisition. In this data acquisition, we will develop some minimal protocols for getting rid of each sensor and ensuring the timely capture data. Next is, this is a basic structure of our project. First, in our project model, waste segregation is conducted in 4 levels. There are nothing but biodegradable, non-biodegradable, electrical, and metal waste. Then each level is equipped with a definite sensor to identify the type of waste and facilitate the separation process. And this bin reaches its capacity, then triggering the bin's automatic movement to the next stage. Then in our next stage, we have done an innovative approach that is nothing but efficient and systematic waste segregation that optimizes the use of resources and enhancing the overall effectiveness. Then, why we named this project as BenBot? After finalizing the design, we named the project BenBot because B stands for biodegradable, E stands for e-waste, N stands for non-biodegradable, and M for medical waste. Next, let me move on to the next slide, which is nothing but future enhancements. How we'll enhance our project? First is AI integration. We'll implement an AI for like AI and image recognition, obstacle avoidance, like that. Benbot will give an accurate, if we implement AI integration, Benbot will give an accurately identify and types based on visual features. This improves the sorting precision, reduces errors, the system to learn and adapt over time. Next, we'll enhance with the voice alerts. If we fix an voice alert, it will deliver the real-time audio notifications to the user. Then it's nothing but solar power. Still, it's running with the battery. If we implement or enhance it with the solar power, it will also work through an integrated solar panels using renewable energy and reducing reliance on electricity. By concluding the project, why it's needed to create this project is, this project has really developed into the critical issue of waste segregation and also to reduce the diseases which are affected by the labors. And one more thing, the challenge of waste segregation, complex and multifactor, this project demonstrates that with innovation and community involvement, significant process can be done towards achieving sustainable and reliant accuracy. The development of sensor-based segregation bots represent a single forward in streamlining the segregation process. These are the references which we referred for our project. Thank you for this opportunity.
Thank you for your interesting presentation. So,
Thank you.
yeah. To what extent can sensor-based I mean, your boss can contribute to long-term sustainability goals in urban waste management, can they? I mean, you can apply your bot in any area in the city or anywhere in your country.
Yes, so we can apply it in anywhere in urban or rural environments, sir.
Yeah. So, have you been doing it?
Sorry, sir.
Okay, thank you. Thank you for your answer.
Thank you so much.
Are there any further questions or suggestions from other authors?
No, sir.
If no, then we'll move towards our next presentation. Thank you, ma'am.
Thank you so much, sir.
So our next presenter is Satyakrishna Nuna, who will be presenting his paper on improving information retrieval task with asymmetric diverse. Any author or co-authors of this paper in the session?
Yes, sir. Am I audible?
Yes, ma'am, you're audible.
I'll share my screen once the previous author stopped her screen sharing.
Sure, sure, yes. So you'll be presenting on behalf of Satya Krishna, sir?
Yes, sir.
Okay.
Uh,
Yes, ma'am, you can share your
yes,
screen
sir.
now.
Share. Is my screen visible?
Yes, your screen is visible. You may proceed with your presentation.
Okay, thank you. Hello everyone, my name is Sriya P and today I'm here to present the paper Improving Information Retrieval Task with Asymmetric Divergence from Randomness in Query Expansion, which was written by the co-authors Lovely Yashwant Panchamarthi, R. Satyakrishnanunna, Lavanya Pachuri and Yogeshwar Reddy Kallam. So our agenda for today, the agenda goes like this. The presentation, I'll start with the abstract covering the motivation and the key contributions, and it will be followed by the introduction and related works, and then I'll explain our proposed methodology and then experimental setup along with the corpus statistics, comparing it with the baseline models and also with the performance with KN, RM, and Vanilla BERT, which are neural models, and then the result analysis, and we'll get into the conclusion. So let me quickly jump into the abstract. To begin with, let's quickly summarize the motivation and contributions of this work. So, query expansion is a critical and challenging component in IR systems. Is right, and while conventional expansion methods tend to treat the term relationship symmetrically, and also they often rely on frequency based relevance, like they can introduce noise or dilute the original intent. So, to overcome this, in this work, we proposed a novel approach using asymmetric divergence from randomness to guide the query expansion. We did this by prioritizing terms that introduce meaningful and directional information gain. Our method consistently outperformed both the traditional and neural retrieval strategies on the datasets which we used on domain specific. And then our objective, like i- if we come to the introduction, the information retrieval is a foundational task in many real world applications, like from search engines to digital libraries. But here comes the primary challenge, which remains like how do we retrieve documents that best match the user's true intent? And coming to the solution, one popular technique to address this is query expansion, where we augment the original query with additional or semantically relevant terms. However, the challenge remains where if the noise is introduced or relevance is misjudged. To overcome that, our work investigates how we can better refine the expansion using asymmetric divergence. And we focused on tackling some of the fundamental limitations of traditional and neural IR models, particularly in understanding user intent and improving result relevance. So the related works which we focused uh, in this domain has the techniques like pseudo relevance feedback, vector space modeling, and neural ranking mechanisms. While these have advanced the field, they still suffer from the symmetric treatment of term importance and a lack of robustness when dealing with sparse or ambiguous queries. And also recently, there has been an interest in leveraging probabilistic divergence like KL divergence, which we used to better model the discrepancy between query and document distributions. Our work builds on this idea, proposing an asymmetric divergence method to selectively expand queries in a way that emphasizes the information gained, where we try to gap the bridge between the techniques which are already there. So our approach is basically we used KL divergence, Kullback-Leibler divergence between the term distribution in a set of pseudo-relevant document, and we also use the entire corpus.
So this helped us in measuring how much information is gained by including a term. If a term is common in relevant docs but rare in the background, it gets a high asymmetric score. And unlike some symmetrical metrics, this approach prioritizes terms that add unique information, improving both recall and precision. So we mainly focused on recall and precision along with some other metrics. And then our framework goes like this. There will be this document collection where the document collection is pre-processed and then indexed. So in the pre-processing, we pass the RDF content and filtered the unique language papers using the language attribute. And then we also cleaned by removing extra spaces, punctuations, hyperlinks, and we also formatted all the inconsistencies. We also removed the stop words, and then we also reduced to all the words to the root forms. So, and then it was indexed. Here we cleaned the corpus and we divided it further into physics and computer science domains and was indexed using the PyTerrier framework. And then this document which we indexed along with the query given is passed into the retrieval algorithm, and we obtained our first set called, we named it as like local set D. And from that, again we took the query and then we again took the query along with the first local set which was generated, and we passed it to the KL divergence mechanism which we used, asymmetric KL divergence, and then again it was passed to the retrieval algorithm, and then we got the final re-ranked algorithm results. So the basic experimental setup for our experiment, we used the data set of Microsoft Academic Knowledge graph data set, which includes metadata like for over 240 million scholarly articles were there. And then from this, we extracted two curated data sets, like I mentioned, a computer science collection and a physics collection. And we proposed each dataset with relevance labels and used multiple retrieval pipelines and evaluation metrics. We used include recall, precision, and DCG. And our system was evaluated under both traditional scoring and neural ranking settings, allowing us to test performance across IO paradigms as well. Coming to the corpus statistics, for our empirical evaluation, we used the dataset which I mentioned, and here we can see, as it mentioned, the documents which were there, the unit terms, postings, tokens. We consider these all. These are the statistics, and you can see the numbers which were there in the physics collection and the computer science collection. And these collections allowed us to test our approach in both technical and theoretical disciplines, ensuring robustness across different academic domains. And then coming to the baseline model performance, we compared a method against this like different models, baseline models. And as we can see, the performance of baseline models vary, like often depending on domain. And then some models overfit to frequent terms or fail to generalize. And there are many inconsistencies also we emphasize. So there is a need for a better expansion mechanism, one that adapts to context while maintaining the semantic focus, where it is achieved in our model, which is, as you can observe in the slide, performance with KL divergence. All the base models, when applied with this KL divergence mechanism, got better precision, recall, and DC, and all, both in the computer science dataset and in the physics dataset which we took. And what's particularly notable is the consistency of improvement even across different query types and domains. And then if we go to the performance with KNRM, which is like kernel-based neural ranking model, these models like learn soft match features between queries and documents using kernel pooling layers. And when we compare this with the KNRM and also with the vanilla BERT, which is a transformer, uh, both the in both the datasets we observe that the precision recall and all the other metrics which we compared are low when we see with our model KL divergence. So, the point here that should be noted is like, despite the deep representation learning, these underperformed compared to our divergence-based approach. This shows that, like, without strong initial query understanding, even sophisticated models can also fall short. And this reinforces the idea that domain-specific enhancements to query formulation, like asymmetric divergence, can outperform even if the state of the art deep learning methods when applied thoughtfully. So if we come to the result, so across our experiments, like we saw that KL divergence consistently outperformed traditional feedback models and also neural methods, while promising struggle with domain specificity and query noise. The asymmetric nature of our divergence method helped isolate terms that truly contributed to relevance rather than diluting the query. So these findings demonstrate the potential of combining our classical probabilistic ideas with the modern data scale, and the evolution could be rigorous. And then to conclude, as we said, the key findings include asymmetric divergence from randomness is a novel framework for query expansion, and our method improves upon both traditional and neural baselines in precision, recall, and robustness. The asymmetric scale divergence helped in refining the query intent more precisely, leading to better relevance and user satisfaction. And these were some of the references that we used while writing this paper. And also coming to the future work, we aim to further refine the scale divergence based scoring mechanism and investigate its integration with complementary query expansion and ranking techniques to enhance it better, to enhance this retrieval effectiveness more. And we would also like to explore on assessing the scalability and domain adaptability of this proposed method. And thank you. Thank you for the time.
Thank you for an inspiring presentation. I don't have any question for this. Thank you.
Okay, so if there aren't any further questions or suggestions from other authors, we'll move towards our next presentation. Our next presentation will be Mr. Satyakrishna Nuna, who will be presenting on the paper modified cross encoder for two-stage passage ranking.
Hello, sir. Can you hear me?
Hello.
Yeah, hello, sir. I will be presenting behalf of the Satyakrishna.
Okay, sir. Sure. You may proceed with your presentation.
Hello, sir. Can you see the screen? Hello.
Yes, sir. Your screen is visible and you're audible. You may proceed with your presentation.
Okay. Good day, everyone. Welcome. I am presenting on the paper modified cross encoder for two-stage ranking. In this talk, I will be explaining how we combined a novel scoring mechanism with a two-stage ranking model to improve retrieval accuracy in information retrieval task. This is the agenda of our presentation. And introduction. In today's world, search engines must process enormous amounts of data in real time. Traditional ranking models like BM25 often rely on lexical matching and can avoid overlook semantic relationships. So our work focuses on passage ranking, which is more granular than document level ranking. We aim to re-rank passages so users see the most relevant content at the top. This wrapper introduces a modified cross-encoder that leverages pre-trained transformers and a novel scoring mechanism. If we take the existing approaches and the gaps, we had sparse encoder, we had sparse encoder, which relies on sparse expansions for representations, bridging lexical matching and learn features. And BM25 is a classical sparse retrieval method focusing on keyword frequency. And the dense method, which is dense by encoder, which learns dense embeddings for queries and documents, captures semantic relations between the both query and the document. And the cross encoders, which are also an hybrid models, directly encodes queries and documents together, but uses mainly logic based scoring. Our problem statement is how can we effectively rank large collection of documents or passages so that users quickly see the most relevant content, given that purely sparse or purely dense methods each have limitations. Our objective is improve relevance, achieve higher precision and ranking quality by leveraging both classification based and embedding based signals, and maintain efficiency, ensure the system remains viable in large scale research by using a two-stage framework, and validate on metrics outperform baseline methods including BM25 and standard cross-encoder model on the metrics like NDCG at the rate 10 and AP at the rate 100. Our two-stage ranking overview. A two-stage approach is a popular framework in information retrieval. Stage 1 is an initial ranking which we use a fast but potentially less precise retrieval model like BM25 or by encoders like sparse encoder or dense encoder to generate a short list of candidate passages. At the second stage, we usually use the most powerful re-rankers, which are nothing but cross encoders. This division allows us to handle very large collection of dataset while still uh, benefiting from high accuracy neural methods for the final ranking. And when we see our architecture of the modified cross encoder, we have used two pre-trained models, Distilbert and Robert AI, and we have used two input representations for the loss calculations, which are query tokens and document tokens. And our output is a logits and the token embeddings, which is used for cosine similarity. This is our mechanism. Here for the input, we concatenated the query terms and the document tokens into a single sequences, and we have given process this sequence through a transformer models, which is robot and digital bot models. And from the uh, last below layers, we have extracted the embeddings, which represents query and the document embeddings. We find cosine similarity of the embeddings, and also at the final layer, we have extracted the sigmoid values and we have calculated the scores, and we have combined the both the scores to use as a combined loss of our architecture. Like two-stage ranking architecture is nothing but first we will process the queries and the documents based on a retrieval model, which can be BM25, sparse, or dense encoders, and we will get some retrieval results, ranked list, and we will re-implement, re-rank those ranked list based on the queries, and we will get re-ranked list of our queries. And regarding loss function and objectives, our loss function is a combination of sigmoid cross entropy loss and cosine similarity. In sigmoid cross entropy loss, we treat the extracted logits as a binary prediction, which is like are relevant versus non-relevant. For the cosine similarity, we also compared the predicted cosine similarity with the ground truth, which is 1 is for relevance, 0 is for non-relevance. We sum up these two losses, so the model is gently optimized to assign higher logistic probability to the positive query terms and increase the cosine similarity for the relevant terms. And experimental setup, we have conducted our experiments using NVIDIA B100 GPU from Google Colab, and our training data included query document triplets consisting of positive passes known as a relevance, negative passes known as a non-relevance. And we also have a first stage encoder which is BM25. We have for the tokenization we used Roberta Distilbert for efficient text tokenizing. These are the collections for training query dataset for the first stage ranking, and this train triplets dataset for the re-ranking.
Excuse me, sir.
Yeah, hello.
Sir, you have 2 minutes of time left. Please
Yeah,
try to conclude your presentation in the given time frame.
okay. This is the hyperparameters we have used, and when we come to see the results, we can see that our modified cross encoder outperformed all the other models, but we have seen similar performance to sparse bioencoder in few comparisons. And when we compare it with the base cross encoder, we perform more than that one. With the reason behind the highest accuracy is the loss function which we designed dual score function using logits and also cosine similarity, and also the regularization which we use for dropouts to avoid the overfitting, and using the transformer model like Robert and Distelbert for our tokenization and also for fine tuning. In conclusion, our modified cross-encoder significantly improves passive re-ranking by leveraging a pre-trained transformer for both logics based on cosine similarity, combining the signals in a unified training objective that reduces overall loss of the model, outperforming all the baseline models like BM25, dense bioencoder, sparse bioencoder, and standard cross-encoder. That's it. Thank you. Any questions?
Thank you for your presentation. So your model improves document ranking for search engines, and
Yeah.
but nowadays many users rely on tools like ChatGPT or other chatbot instead of traditional search engines. So, in your opinion, what challenges or changes that might bring to information retrieval systems?
Like it depends on the task. Like for passage ranking, the re-ranking is the best one because the passages are too long. We can't use a single ranking and get the efficient. For the document ranking, I think the efficient one is the query expansion, those kind of domain specific.
Thank you, sir.
Thank you.
That's the question.
Are there any further questions or suggestions, remarks for the paper? Okay. So if no, we'll move towards our next presentation. Our next presentation will be Anjana S. will be presenting a paper on brain tumor detection and classification using K-means segmentation method. Ma'am, are you ready with your presentation?
Yeah, hello. I'll be presenting.
Okay, so may I know your name?
My name is Anand. I'm a co-author.
Also, your name doesn't seem to be in the co-authors.
Uh,
Is any co-author Anjana S herself in the meeting?
One second. Hello, sir. Yeah, my name is Shivaraj Api.
Okay.
Okay, may I start?
Yes, you can start.
I'll share my screen.
So, are you presenting on behalf of Anjana S?
Yeah, on behalf of Anjana S.
Okay, then the presentation certificate will be issued on name of Siva Raja, right?
No, on the name of Anjana S only.
Okay, that is no problem. We will be issuing the certificate on Anjana S.
Yeah, it's a,
Okay, no problem. Thank you. Go ahead.
yeah. Okay, is my screen visible?
Yes, sir. Your screen is visible. You may proceed with your presentation.
Yeah, so good morning, everyone. I'll be presenting my paper, which is on brain tumor detection and classification using k-means segmentation method. So, on a brief introduction about our paper, so on brain tumors. So, brain tumors occur due to an abnormal and uncontrolled growth of cells, which depletes the brain of essential nutrients. Shockingly, nearly 1 million new cases are diagnosed annually, and brain tumors rank as the second leading cause of cancer related deaths among individuals that are under the age of 34. These alarming statistics highlight the urgent need for early and accurate diagnosis. Traditionally, physicians have relied on invasive and often uncomfortable procedures to detect malignancies. Fortunately, advancements in medical image techniques such as medical resonance imaging (MRI) and computer tomography (CT scans) have transformed how we diagnose and analyze brain tumors. MRI in particular has become an essential tool for medical imaging, allowing doctors to examine internal structures without surgery. However, with the increasing availability of massive volumes of healthcare data, there is growing need for rapid, objective, and automated analysis. This is where AI and deep learning steps in. Using MRI scans from different patients, our proposed study aims to detect brain tumors and classify them into different categories using a hybrid approach. So we had actually gone through over 15 literature reviews in order to get all the materials and resources for our paper. The three main are actually listed here. So now let's take a closer look at the materials and methods used in our research on brain tumor detection. The key objective of this study is to combine machine learning techniques with feature selection methods to accurately identify potential disease from medical images. To enable early detection of medical brain tumors using MRI, CT, and X-ray images, we employ a combination of image processing and deep learning algorithms. So these advanced techniques allows us to analyze and classify medical image with high precision, reducing the chances of human error and improving diagnostic efficiency. Before feeding the images into our model, we must ensure the quality and relevance of our data. Therefore, the data set must undergo pre-processing and partitioning, where we remove low quality and or irrelevant images from different regions. This step ensures that only clear, high resolution and relevant medical scans are used in the training and testing of this model. At the core of our system is a convolutional neural network or CNN, a powerful deep learning model for its exceptional ability to recognize patterns and features in images.
Excuse me,
So
sir.
yeah.
So I just wanted to know, are you changing slides or is it still on the
No,
first
no,
slide?
no, no. It's still on. No, I'm actually changing. It's materials and methods right now, right?
No, actually we are able to see the title slide only where the title is mentioned.
Oh, I'm sorry.
Yeah, now the slides were changing.
No, now you're not able to see the change in slides.
No, but previously when you were moving the cursor that time, Now the
Okay,
slide you
now yes.
mentioned is there.
Okay, then I'll present it like this. Yeah.
Yeah.
Okay, so the execution process of our model follows a structured framework. So initially we perform pre-processing, which is basically cleaning and enhancing the data set. Next is the feature selection, feature extraction. It identifies key patterns and characteristics in the images. Then we come to model training. It uses a CNN to learn from labeled MRI, CT, and X-ray scans. And finally, its testing and detection is done by applying the trained model to new images to detect tumors. So now let's come to the first step, which is the essential step in our brain tumor detection. This process is the foundation of our study, as the accuracy of any deep learning model depends heavily on the quality and diversity of the data set. So in image acquisition, we collect images from clinical data sets. These data sets include MRI, CT, and X-ray scans that both contain abnormal and healthy samples from various individuals. The goal is to ensure that our model learns to distinguish between tumor-affected and normal brain scans with high accuracy. Medical images can be obtained using specialized imaging equipment such as MRI or through artificial data sets, which are curated collections of labeled images used for research and training purposes. So we have used a data set available from Kaggle, which is an online platform that provides data sets for research. Next, this is our proposed architecture. So the first step is data preparation. In this step, the first step in this process is collecting a data set for brain MRI scans. However, raw medical images often contain noise and variations. So we begin by applying pre-processing techniques. These include noise reduction, contrast enhancement, and resizing to ensure that the images are clear and standardized. Next, we apply a normalization to bring all pixel values to a common scale. This helps the CNN model learn patterns efficiently without being affected by variations in image intensity. The step two is model training. Once the dataset is ready, we divide it into training and testing datasets using a technique called cross validation. This ensures that our model is trained on one portion of the data while another portion is kept aside for evaluation. For training, we extract critical features from MRI scans such as tumor shape, texture, intensity, variations, etc. After selecting the most relevant features, we feed them into a CNN classifier, which learns to distinguish between healthy brain tissues and tumor affected regions. The results of these training processes is a trained model, which is now capable of analyzing new MRI scans and detecting brain tumors with high accuracy. Next, we come to model training and prediction. So next we come to model training and prediction, in which these data are used to train the model for prediction and for prediction of real world data. Finally, we come to performance evaluation. So we compare its predicted diagnosis with the actual ground truth labels provided by the medical experts. By mapping these results, we analyze the model's accuracy, fine tune it, and continuously improve its performance to ensure that it can assist doctors with precision and trustworthy diagnosis. So let's now look at all the steps in more detail. So first, it's pre-processing. Since the medical images we collect from come from different sources, they may have inconsistencies such as distortions, blurring, or noise. To overcome these issues, we apply pre-processing techniques to enhance image quality. This involves resizing the image, converting it into a standardized format, and removing unnecessary artifacts. The HSI color space is used to improve color perception, making it easier to analyze critical regions in the brain scan. Additionally, masking techniques are applied to hide irrelevant pixels and highlight the essential features. Next, we come to extraction of features. After pre-processing, the next step is feature extraction, which is a crucial part of image analysis. We extract relevant information from medical images using advanced image processing techniques. The goal here is to
Sorry to
highlight
interrupt you, sir, but
yeah,
you have 2 minutes of time left. Please try to conclude your session within the given time frame.
yeah. So the tumor affected areas are more clear once the feature extraction is done. So we use methods like principal component analysis, information grain, relief F, attributed analysis to select the most meaningful features that can help in tumor classification. Next, we come to feature selection. Since the medical images contain vast amount of data, selecting only the most relevant features is vital for efficiency and accuracy. Feature selection helps the system distinguish between normal and tumor-affected brains. Okay, then we move on to the final and most critical step, which is classification and recognition. So here we use deep learning models to identify whether a brain scan shows a tumor or not. Okay, now let's look at the results and a few discussions on our paper. So, for the training model, we used Kaggle dataset consisting of different files such as CSV, DAT, RGB, and HSV files. And we have finally done performance comparison with our models using multiple training algorithms. So this table basically shows the performance metrics using machine learning and proposed CNN classifier. So we performed our models on a 70-30 split and a 80-20 split. So the various results are shown here, and this result is for a 80-20 split. So finally, our performance on a 80-20 split, on a 70-30 split were seen more accurate than on an 80-20 split. So now, in order, as we conclude, our main goal was to develop a fast, reliable, and efficient system for automated brain tumor detection. While traditional machine learning classifiers can perform tumor classification, they often suffer from lower accuracy and higher processing times. To overcome these challenges, we introduced a deep learning-based approach using CNN. By leveraging MRI scans and the Kaggle dataset, our proposed method significantly improves the classification accuracy while reducing computational costs. Our findings show that the number of convolution layers directly influence the accuracy. More layers lead to better results, but also increasing the training time. To further enhance performance, we employed image augmentation, which improves the model's ability to generalize across different tumor types. Thank you. Hello.
Yeah, thank you for your presentation. Your research provides valuable contributions to the medical field, especially in early cancer detection using deep learning technologies. And I just have a question: how applicable is this system in real-world clinical environments?
So actually, our method, it is actually much faster and more accurate than most of the methods that are currently available, because we integrate multiple models in order to perform this, and we have used pros of other research works. This actually makes our model much more relevant for real-world applications. As we saw, the like our model actually performed 95% accurate on the training data set, which I believe is pretty competent for the.
Yes, thank you for your answer. And do you think this approach can be scaled or adapted for use in hospitals across different countries with varying levels of technology infrastructure?
Sorry, can you?
Yeah, do you think that your research can be scaled or adapted for use in hospital across different countries?
Yeah, absolutely.
Yeah, thank you. That's it for my question.
Okay, so are there any further questions, suggestions, or remarks on the paper that was presented right now? If no, thank you, sir. We'll move towards our conclusion. All the presentations for session 9A have been presented. So I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this was an informative session for all of you. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters, take a note of it that you will be getting your digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team ICTIS 2025. I also thank our session chair for chairing this session. This is a token of appreciation to the chair on behalf of team ICTIS 2025 and Global Knowledge Research Foundation and partners. I thank you all for your valuable presence. Now I kindly request you all to switch on the camera for a quick snapshot of the virtual conference.
I'm sorry, my camera doesn't work. Sorry.
Yeah, sure, no worries, sir. Rest of the authors, if you could just turn on your cameras. Okay. So thank you all once again. Stay safe and take care.
Thank you so much for all the presenters and also the moderator today. Thank you.
Thank you, sir.